Hey everyone, today we're going to take my old terminal-based C program and give it a modern makeover by creating a graphical user interface, GUI, using GTK. I'll show you how to install GTK and create a simple GTK program that takes a student's details and marks and calculates them and assigns a grade. I decided to go with GTK for many reasons. It is cross-platform compatible and also has a rich ecosystem of widgets and libraries which can be used for multiple languages. Now, let's install GTK on Windows. First, we head to the GTK website. I will use MSYS2 packages to install GTK and download the installer for Windows. Next, just run the installer and follow the instructions. Next up, we need the GCC compiler to build our C program. If you don't already have it installed, follow these steps. But remember, if you have GCC installed, there's no need to do this. All right, now that we have GTK and GCC set up, let's dive into the code. I've already prepared a basic example to get us started. You can find the link to download this project in the video description below. It's a simple GTK application that creates a window with a title and a default size of 200 by 200 pixels. We've also added a callback to handle the Windows destroy signal, which ensures that our application exits gracefully. Now let's compile it. If you encounter the following error, then do the following. Ensure that GTK3 is correctly installed in your MSYS2 environment. You can do this by running the following pacman command. The next step is to set the pkg-config path environment variable to point to the directory containing gtk3.pc files using the export command. Make sure to choose the appropriate path based on your system's 64-bit or 32-bit. After setting the pkg-config path environment variable, you can try running pkg-config again. Finally, compile the program while including the GTK3 flag like this. Alright folks, before we dive deeper into our GUI transformation, let's take a quick trip down memory lane and look at our legacy C program. This is what we used to have, long nested if statements and a whole lot of terminal text. Let's run it one last time for old times' sake. It takes student details, subjects' names and marks, calculates the total, highest and lowest scores, averages, and assigns a grade, all in the terminal. A true relic, isn't it? Now let's get back to our GUI transformation. Let's first learn the basics from the previous code snippet and break it down step by step. The first thing we do inside our main function is initialize GTK Plus using GTK3 init. Next, we create a GTK Plus window using GTK3 window new that is displayed on the screen. With the window created, we can now customize its properties. We set the window's title using GTK3 window set title and set the default size of the window to 200 by 200 pixels using GTK window set default size. We want our application to respond when the user closes the window. We achieve this by connecting a callback function, GTMainQuit, to the destroy signal of our window using gsignalConnect. This ensures that when the user clicks the window's close button, our program quits gracefully. After configuring the window, we call GTK3 widget show to make it visible on the screen. Lastly, we enter the GTK Plus main loop with GTKA main. This loop handles events such as user input and window updates and keeps our application responsive. It continues running until GTK main quit is called. In this section, a new scrolled window widget is created and stored in the A variable. This widget will act as a container for other widgets, allowing them to be scrolled within it. This section creates a new vertical box widget and stores it in a variable. A GTK box is a container that arranges its child widgets either horizontally or vertically. This line creates a new label widget to display text in the UI. The next line creates a new entry widget which can be used for capturing text input from users. Then we cast the box variable into a GTK box type. This is the widget that we want to add to the box container. This parameter specifies whether the child widget should expand horizontally to fill available space within the box. This parameter specifies whether the child widget should expand vertically to fill available space within the box. This parameter specifies the amount of padding to add around the child widget. This line creates a new separator widget that takes one argument, which is the orientation. This part creates a GTK Plus grid container and configures it by setting the spacing between columns and rows to 10 pixels each. This spacing helps control the layout and alignment of widgets within the grid. We have two buttons, one used for a callback function and the quit button closes the application. The entry widgets for name, ID, course, and number of units are stored in a struct named student. This helps simplify data retrieval operations when working with users' input. The widget struct has three members, grid, window, and student. The grid member is a pointer to a GTK widget object, which represents a grid widget. The window member is a pointer to a GTK widget object, which represents a window widget. The student member is a pointer to a student object, which represents a student object. This section then allocates memory for a widget's object using the gmalloc function, which takes the size of the object to be allocated as an argument and returns a pointer to the allocated memory. Once the memory for the widget's object has been allocated, the code sets the student member of the object to point to the student object and the window member of the object to point to the window object. The gsignalConnect function is used to connect a signal to a callback function. A signal is an event that is emitted by an object when something happens to it, such as a button being clicked. A callback function is a function that is called when the signal is emitted. The first argument is the object that emits the signal. In this case, the objects are the two buttons, process button and quit button. The second argument is the name of the signal. In this case, the signal is clicked. This means that the callback function will be called when the button is clicked. The third argument is the callback function, and the last argument is usually optional. It is a user data pointer that is passed to the callback function when it is called. In this case, the user data pointer is widgets and null for the quit button. The first line of code shows all of the widgets in the window. And finally, we start the GTK main loop. Here we cast the data pointer to a widget pointer. This is done because the data pointer is pointing to a memory location that contains a widget's object. The widget's object contains pointers to a GTK-Bo widget object and a student object. The code then assigns the window and student pointers to the corresponding pointers in the widget's object. This is done so that the window and student pointers can be used to access the GTK widget and student objects respectively. This code does two things. First, it gets the text from the input fields in the GUI. It does this by calling the GTK3 entry getText function for each input field and returns a pointer to the text in the input field. Second, the code copies the text from the input fields to the student struct. It does this by calling the stringp function for each member of the student struct, which copies a specified number of characters from one string to another string. This code collects the unit names and marks from the input fields in the GUI by iterating over the unit entry and mark entry and copies it to the arrays. This code calculates the total marks, average, highest scored unit, least scored unit, and grade for a student. The first part calculates the total marks and the highest and lowest scored units. It does this by iterating over the unit marks array and adding each mark to the total marks variable. The code also compares each mark to the highest mark and lowest mark variables and updates the variables accordingly. The second part of the code calculates the average mark by dividing the total marks by the number of units. This part then assigns the student's grade based on the average mark. We then create the second window and set its title, border width, and size. The second part creates a scrolled window and adds it to the second window. The third part then creates a box for layout and adds it to the scrolled window. We then create a label and a button that will be used to create a new student record. The third and fourth lines of code add the label and button to the box in the second window. This part then creates a new grid like before and sets the column and row spacing. We then iterate over the unit and marks arrays and create a new row for each subject. For each row, the code creates two labels, one for the unit name and one for the unit mark. The third part of the code adds the grid to the box in the second window. This part of the code creates three label widgets. The next part formats the student's name, ID, and course name as strings, and then we set the text of the labels to the formatted strings, followed by adding the labels to the statistics box in the second window. Finally, we can display all widgets to the second window. The GTK main quit function quits the GTK main loop and closes the program. Here's the final result. That's it. Thank you for watching.